Hey guys, Miss Harrison here. We are working on the first part, Pascal's 12 patterns of Christmas. And it is like November 9th, or not right now it's October 23rd. But on November 9th, when we actually put this together, we're entering the holiday season. I know a lot of people don't like to skip Thanksgiving, but we are not. We're celebrating family and togetherness, and we're gonna actually make these into ornaments. So you can do them online using Google Slides, or you can print them out and you can make them into ornaments. So Pascal has some really cool patterns, and we're gonna talk about them. This is kind of like the answer key to help you go through. I'm gonna go ahead and put this down on my paper. All right, so the first pattern that you're gonna be looking at is counting numbers with bilateral symmetry. So you're gonna wanna write that down for number one. Counting numbers with bilateral symmetry. Okay, so you've written that on your first pattern. And you're gonna color or circle the counting numbers in blue. So let me get my colors. First, we want to draw a line of bilateral symmetry. And bilateral symmetry is like that of a butterfly's wings. So pick a color and draw a line down, just like so. And then we're gonna outline the counting numbers in blue. So let's do that together. You can see that second diagonal row is an example of the pattern. And also here, we see another example. So for counting numbers with bilateral symmetry, this will be the first pattern of our 12 patterns of Christmas. Our second pattern is powers of two. So you're gonna wanna circle each row in a different color. Well, first we gotta write powers of two, sorry. Pattern number 2 is powers of 2. So we're gonna take our pen and we're gonna circle it, each one in a different color. So this is 1. You could do rainbow color if you want. It's a wonderful order. Red, orange. I'm gonna do a peach in the middle. It's not quite rainbow, but I have it, so I'm gonna do it. Red, orange, yellow. A lot of people do the numbers in 6, but there's actually 7. Green in the rainbow pattern, because you've got blue, indigo, violet, right? Blue, and I'm gonna do a little more. So lighter blue maybe. And then a darker blue. Oh, about the same. And then let's get a purple. Oh, I got this purple. Let me use purple. All right. And then you're gonna figure out, okay, well, what are the different powers of 2? Well, 1 to the 0 power, or 2 to the 0 power. 1 equals 2 to the 0 power. 2 equals 2 to the first power. 4, because you're adding up these numbers, equals 2 to the second power. See the patterns that we see? And then 8, when you add all these up, equals 2 to the third power. And 16, when you add all these up, equals 2 to the fourth power. And then 32, when you add all these up, equals 2 to the 5th power, not 25. And then 64, when you add all these up, equals 2 to the 6th power, which is 2 times 2 times 2 times 2 times 2 times 2. And then if you add all these up, you get 128, and that equals 2 to the 7th power. So we see powers of 2 here. See? All right, our third pattern is triangular numbers. So I want you to write triangular numbers down for pattern number 3. And it's gonna be right here that we see these numbers. These are numbers that you can fit in a triangle. So I'm gonna use this tree-shaped triangle, dot, and then 1, 2, 3, and then 1, 1, 2, 1, 2, 3, and then 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, and then 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, it's got these triangular numbers here. Those right here, triangular numbers. All right, then the third pattern is the Fibonacci sequence. Fibonacci, right? So you can kind of circle in the patterns sideways. So you've got here, here, here. Let me do this so that I'm doing it right. So I'm circling the alternate numbers, just like this. Oh no, I think I made a mistake. No, we're good. All right, and then circling these red right here. And then I'm circling the blue.
You got it?
Oh, I didn't do it yet.
You got it?
I hadn't done it yet. Thanks. And then I'm gonna circle these right here. And then I'm gonna circle these right here. And then I'm gonna circle these. And then here. And here. And here. And it just keeps going, right? But it really stops this one, I think, because you're getting the back end. So they're gonna add up to the Fibonacci sequence. So you got 1, 1, 2. I'm gonna write it with my pen. So it's the Fibonacci sequence. So I just wrote fib sequence. 1, 1, 2, 3, 1, 1, 2, 3, 5, 7 plus 1 is 8, then that's 13, then that's 21, and then that's 54, and then that's 65, right? 7 plus 15 plus 10 plus 1, so that's 25, 26. Am I doing something wrong? It is 54. And then here we're looking at all these. It looks like the pattern stopped right here actually. So you won't go this far. So yeah, you're going from 1 to 21 because this pattern's off. Cool, okay. So you've got that right there with your Fibonacci sequence. All right. And then pattern 5 has to do with prime numbers.